Hello, welcome. Re-recording some lecture videos. Keep things up to date. Welcome to first lecture of chapter 4. It's 4.1. We're going to talk about sampling and surveys and how we get the data to do the statistics. First time looking at a set of lecture notes for me. I got a vocabulary sheet. First few pages of the packet. You're going to need to make some vocabulary cards. Think about AP psychology and making some vocabulary note cards for that. Oh, got some note cards around in the classroom. You ask me, I'll give you some. We're not going to spend time making a vocab uh, note card set though. In the video, we're going to jump right into notes. If I'm writing it down, you're probably writing it down too. I've got a highlighter too. You know, got a computer or calculator at the ready, but we're not going to really use that at all in chapter 4. Because chapter 4, you're going to find out a lot about writing, describing what we're doing, describing what we're trying to find out, and why we're justified in using the procedure we're using. So you're going to find out beginning of this course, it is a lot of vocabulary. And that's what most introductory science courses are going to be, learning a lot of vocabulary and seeing how they play together. So if you see bolded things in here, it's a vocabulary word, and it's telling you, hey, this is going to be important. And if you can learn what this means, you can write kind of denser answers to questions without having to ramble on and on. If you can use the vocabulary, you can get to the point a lot quicker. So let's jump in. If I'm writing it down, you're writing it down too. You can put this on double time if you like to watch real fast, 1.5. If you think I'm slow, I don't care. But you should probably be writing down what I'm writing down. What are we talking about? Where we want to get the data from. First thing, we got two big words we're going to talk about over and over. What's the population? What's the big group versus what's the sample, the smaller group we're going to learn about? Because we don't usually talk to everybody. That thing where we talk to everybody, census, we don't do that very often. Every 10 years, what's the deal with a census? It's a lot of work. It's hard to know about everybody. So usually we're going to use the sample to gain knowledge on the population without talking to everybody. We can take a census, we can talk to everybody, but it's a lot of work. We don't do that often. It takes time. So we're going to talk a lot today about how we get a sample, right? We got this population. We want to know about the population. We want to know how tall the trees are. We want to know how many peaches Dr. Kinchellow's peach trees put out. We want to know this one. That's something we want to know. How long does it take to get out of the parking lot? I don't know. We got some information. The population, that's all the data. The sample, that's the one we want to kind of learn about so we can then infer about the population. This process of inference, that's going from the sample to the population, taking knowledge about your sample and then drawing it for that whole population. Inference. All right, so we've got some definitions down below. We've got this thing called a simple random sample, and you have a very specific definition, consists of size and consists of n individuals. Okay, we're talking to n people, chosen from the population in such a way. Okay, here's the important part. It's kind of a math class, so the definitions are really important here. In such a way that every set of n individuals has an equal chance to be the sample actually selected. So it's not talking about every individual. People hear this and they think it's about every individual. It's not about individuals. It's talking about every set of individuals. Every possible sample is equally likely. Every sample is equally likely. Sorry, my handwriting's bad, but YouTube's going to put subtitles on this, and that's going to be great. So one way we're going to take simple random samples a lot is using something called the hat method. What's that going to be? We're going to take a bucket, we're going to take a thing, and we're going to put a bunch of bunch of pieces of paper in. I don't know what they are, balls, pieces of paper, whatever, and we're going to select names from whatever hat you like. That's going to be one way we talk about selecting a sample. Is that how people select samples in real life? No, they're going to use like a random digit dialer where their phone starts calling randomly selected individuals until somebody decides they want to talk to a pollster on the phone. So we're taking these samples. A lot of the times we're going to take this thing called a simple random sample. That's SRS. I don't know what happened in my R there. Well, okay, we're taking this thing called an SRS. It's going to generate a sample, and hopefully that sample lets us know about the population. Sometimes we got to consider whether when we pull a name out of the hat, it goes back in. You might not say, why is that important, you're thinking right now? Well, do we want to consider the same individual twice? We want to ask Mr. Rask how long it takes to get out of the parking lot, and then ask him again after his name has already been pulled out. Oh, probably not. So we're going to have to consider, do we want to replace or not replace? Put a big old star by this. This is one of those things that's going to have to show up when we're talking about how we gather samples. A lot of what we're going to be doing is describing the work that the actual statistician would do. So here we go. Welcome to AP Statistics, where we do free response questions. You're going to take a FRQ free response question section of your test sometime in May, whatever it is. I don't know. First couple weeks. And one of the questions is going to be about data collection. So here we have a question from 2012. It's question number 6. When you see that up there, that means it's a released FRQ. And the nice thing about released FRQs is you can go look up the answers for them. Google AP Stats FRQ scoring guidelines. If you Google that, and if you say the year that you're interested in, it will point you directly to a PDF that tells you, hey, what's a good answer look like? So take a moment. I'm going to ask you to pause the video once in a while and just read through it, and then say, hey, do I know how to do this? Probably not. Then unpause it and we'll work it together. I'm not going to stop for the time here. So here we go. 2 students at a large high school, Peter and Rainia, whatever, want to estimate mu. You don't know what that is right now, but that's the mean, the average. You know, that's a symbol you haven't seen before. Looks like a U with a tail on the front, means average or mean. Mean number of soft drinks that a student at their school consumes in a week. Great. Complete roster of the names and genders for the 2,000 students at the school were available. Okay, there's 2,000 students at the school, so it's a little bigger than Park Hill High School. What's 2,000 going to be? We're going to represent that sample size with a little n. We don't need that right now, but you know, that's something we're going to teach you about later. Peter selected, okay, here's that verbiage from earlier, a simple random sample of 100 students. I made an error just a moment ago. 2,000 is not the sample. 2,000 is the population. That's the big group. Gets a big N. 100, that's the little sample. Small group. Gets a small N. And then Rainia does something else, knowing that 60% of the students are female, whatever. It turns out we don't actually need Rainia's thing to answer part A because it's about Peter. Describe a method. Okay, so we're going to talk through a method that Peter could have used to select a simple random sample of 100 students from the school. So how is he going to do it? And there are a lot of ways. You could talk about random number generators on your calculator. You could talk about random number generators on your computer. I wouldn't do any of these. You know, I'd go random int. I could give every student a number, a different number, 1 through 2,000. And I could have this calculator generate 100 names for me. It doesn't actually generate 100 names, it generates 100 numbers. And from those 100 numbers, I have to go back and assign them to 100 names. You can describe a process that uses a computer, that uses a calculator. I wouldn't do it. What I would do is describe a process that involves names in a hat. What are we going to do? Write the names of all 2,000 students on equal sized pieces of paper. What's important in there? Equal size. Why is equal size important? Same probability. Somebody with a really long name is not more likely than somebody with a really short name. You don't want that. You want everybody to be equally likely. What are we going to do next then? We are going to put the papers in the hat. We have to do something because we don't want the Z's to be on the top of the hat or the A's. I don't know how we put them in the hat. We probably either put the A's on the bottom and the B's, or maybe put the Z's on the bottom and worked up the A's. I don't know. Whichever way we put them in the hat, we have to shake the hat vigorously. You need to shake the heck out of that hat because we don't want all the Z's on the top and the A's on the bottom. We want to mix it. We want to mix it. What is this second line really about? The second line is really about some random process. That says rand. I shouldn't write with this. What are we going to do then? Okay, we've got all the people represented in the hat. We've put them in the hat. We've shaken the hat. So now they're kind of dispersed, right? What are we going to do now? We're going to randomly select. How many are we taking? 100 slips of paper. Now we have that thing on the last page. What do we have to say about this? Without replacement. We want to talk to 100 different students. We don't want to talk to Peter's best friend twice. All right, so I'm going to go ahead and underline this without replacement. That's pretty important. We got to say that. It's one of those things I'm looking for when I'm grading this exam down in Tampa in June. I get to grade these exams. They pay me to go do it. It's one of those things that we're always looking for. You got to say, hey, don't want to pull them twice. We're not quite done yet, though. We want to say one more thing. The 100 names pulled constitute your sample. We want to say that, hey, we've picked these people, they're in. I know it seems obvious, seems like an obvious statement. We want to say that. I'm not going to do this every time, but I'm going to do this first time. We can look these up on our own. If I go too fast, if you want greater detail, if you wrote something different and wanted to see, hey, is this other way okay? You can look at the scoring guidelines. Let's take a look at how we do that. So we go to pull up Google, whatever, and then we're looking at AP Statistics, free response questions, scoring guidelines, and then whatever the year is. This one's 2012. The first thing that shows up. You've got, great, here we are. This is what it's going to look like. The format changes a little bit from year to year, but this is approximately what we're looking at. And we're on question 6, it looks like. So we go down and we see question 6. Great. What did we do? Well, they describe here a method with a calculator or a random number generator. But you see a very similar format. Peter can number the students. I put names in a hat. And then use a calculator to generate 100 unique random numbers. Unique random numbers, that's the same thing as, can I type in here? Yes, I can, without replacement. Unique random numbers and without replacements are really satisfying the same thing. We don't want to talk to the same person twice. Oh, it says without replacement down there. They've kind of double hit that point then. That's fine. What else we got? Oh, clear all drawings. If non-unique numbers are generated, they're ignored, whatever. We're just talking about, we're putting them back in the hat. We don't want to talk to those people twice. The students whose numbers correspond to the ones randomly generated are then selected for the sample. That's kind of what I was saying earlier. We want to clarify that the ones we've selected then become part of the sample. Okay, so that's what their keyed response would be. We can see, though, that it's graded with this EPI criteria. And we'll go through tons of these in class. Quizzes will be graded according to these. Exams will be graded according to these. It's a structure that AP Statistics grades all their problems by. Essentially correct. That's the best. If the response provides a correct sampling procedure to obtain a simple random sample that includes, this is kind of the vague part, sufficient information such that two knowledgeable statistics users would implement equivalent methods. The descriptions get better the closer you get to 2025. They are a little vague back then. It has some notes, and so you can look and say, hey, did my response, was it weird, non-standard? Does it match up with any of these notes? You're going to see talk of random table of random numbers. We don't want to use that. We're going to be using a hat a lot. The hat is easiest to describe. You're familiar with hats. If you're a comp sci person, if you know random number generators, give it a shot in class and I'll tell you if you're given enough detail or not. But generally, I'm not going to teach the random number generator way unless that's what you're most familiar with. Second camera. All right, so we're back on the notes. We've got multiple choice examples here. Let's take a look. Take a moment. The survey the opinions of the students your high school researcher plans to select every 25th student. People are walking in. 1, 2, 3, 4. You talk to the 25th, and then you reset. And you talk to number 50 and 75 and 100 and whatever. Assuming there are no absences, will this result in a simple random sample? Okay. Well, is every sample, not every individual, but is every sample equally likely to be selected? We have to go back to the definition. You have definitions on the front page. If you want to, you can go back and look. Simple random sample, the basic sampling method at SRS gives every possible sample of a given size the same chance to be chosen. Well, there's some samples that can't be chosen. When you look at this and you're asked, is something an SRS? The question that's often helpful to ask is, are there samples that can't be selected? Okay, well, I can envision one in my head. I can envision one where no, someone and their, I don't know, sister that they walk in school with, they're number like 24 and 25. They walk in together, they're never going to get picked together. Boyfriend, girlfriend will walk in together. They're never going to both be in the sample. So if there are samples that can't be selected, then it's a no. Okay, so we're selecting samples. We're talking about definitions. We've got to go back to definitions in this class because this is kind of a science class, kind of a math class. The definitions are important. All right, what do we have down here on the bottom? We have something that shows up in samples, something that we want to avoid. We want to minimize this thing called bias. We want to minimize bias. What is bias? It is systematically favoring certain outcomes over others. We don't want to do this. In statistics, we want to know the truth. We want to avoid racial bias, political bias, bias from a judge, bias from a police officer, bias from a teacher. You've heard this word in certain circumstances. Bias is like some people get it better than others based on something, or some outcomes are favored more than others. We're going to talk about how bias can appear in statistical studies. We want to minimize it. The sample doesn't accurately represent the population. We want accurate representation. We want a representative sample. We want to make a representative sample. We want a representative sample. These are ways we don't get a representative sample. Types of bias: response, under coverage, response. Certain responses are favored. Under coverage, some people's answers aren't covered. Non-response, well, what if we're not What if the people that we're not hearing back from have certain opinions? Selection bias. Maybe we're picking certain people, and the way we come up with our sample that's not representative of the whole population. And if we just let people respond on a voluntary measure, well, maybe they'll respond, maybe they won't, maybe all the people that don't respond don't care. And then we'll talk about some ways to get bias. We don't want these things. We want to avoid these things: convenient samples, voluntary response samples, bad wording, lurking or confounding variables. We'll talk a little bit about more about all these things. Response bias. Okay. So certain responses were desirable. Imagine Dr. Kinchlow, knife is a knife, goes down and asks you, raise your hand if you've got a vape in your pocket. If there's a vape in your pocket. You're not gonna answer him. Nobody's gonna raise their hand. There's a certain desirability. There's one outcome that is favorable over others. It's unsavory attitudes. Do I beat puppies? Do I use black tar heroin? You don't say yes to these things in public. Even if you do, there's a socially desirable answer, and you're going to give that. Sometimes it's about what's socially desirable. Sometimes the question is, it leads you to an answer. It leads you to an answer. Everybody else likes orange M&Ms the best. What's your favorite color of M&M? Whatever. But there's more consequences on it. Political questions are sometimes worded with that leading thing to make you think a certain way or another way. Things to consider. Do they want the truth, or do they want you to answer a certain way? Selection bias. Well, selection. Who gets picked? Who gets picked? Um, that's going to affect whether the answers represent the whole population. Is the sample representative? Okay, well, was it voluntary? Then only people that self-selected are going to respond. Who responds to voluntary polls? People with strong opinions. Nobody calls into a sports radio broadcast to say, I don't really care how the quarterback's doing. I just want everybody to have a good time. Nobody calls in to say that. People with strong opinions call in. So if it's open to anybody, if it's voluntary to submit your feelings, then people with strong opinions are probably going to respond. Non-response, maybe the people that refuse to participate differ from the people who did. Okay. And then, I don't know, maybe there was a telephone survey and you don't have a phone. Can't be in it. Under coverage, some members of the population are inadequately represented. These all kind of make sense. The words involved in the naming says, oh, this is a way to affect who's been picked. I'm going to skip the next multiple choice example. None of them are good, but you sit down, take a moment, consider why. None of them are any good. I'm going to skip the next multiple choice example, and we'll look at the next two though. We've got some sampling methods. I'm selling my oranges to the Tropicana company, and I want you to buy my oranges. Company inspector looks at 10 oranges from the top of each crate before deciding to buy all the oranges. For each of the following situations, identify the sampling method used. Top of each crate. What have we done? We've taken something called a convenience sample. Taking a look back, ways to get bias. It says convenience sample. I didn't even put a definition of it. The definition's in your notes, but if you know what the word convenient means, you can probably figure out a sample taken by selecting the members of the population that are easiest to reach. Is this a good sample? Is this a good method? Probably not. Why not? Convenience sample. Maybe the farmer But what would the farmer maybe have done? He wants to pass off his oranges as good. Maybe the farmer put the best oranges on top. We should probably pick throughout the whole box, not just pick the ones off the top. What's the problem with that? May not be representative of all oranges. Hey, you're going to write a lot in AP statistics. Have they figured that out yet? Here's a program you don't watch on TV anymore, something called Nightline. It's like a news program for old people that you don't watch. And it asks people to call into its headquarters, respond yes for one thing or no for another. I don't know what we're asking about. Should we invade Iraq? This is the last time anybody cared about Nightline. There was no charge for calling. Also, money's not an issue. You got to have a phone. More than this many people called and said no. Well, who calls on this stuff? What kind of situation was used here? This is a voluntary response polling. Who responded? People that wanted to. People with stronger opinions are more likely to call. Nobody calls in on a poll and says, I don't care. I really don't care. I strongly don't care. Nobody's that strongly ambivalent. So you got to consider how could this have been manipulated? Why might these numbers not represent the whole population? May not be representative of all voters. You want some good news? I'm going to skip this entire page. This is an outdated method. Outdated selection method. It's like drawing numbers from a hat, but instead of the numbers being in the hat, they were printed out on a piece of paper for you already. So don't worry, I can spell, about random digit tables. You got a problem on the homework, it says you got to look at a random digit table. You can do it. It's probably going to make sense. You can also skip it. I've just given you permission. Up here is a similar description to the hat method. Instead of having names on a hat, we're putting numbers on a piece of paper. And instead of saying don't put the number or the name back in the hat, we're saying don't read the same two numbers twice. Oh, look at that. We get another one we can skip. What good news. This is very old. This is older than you. This is, God, might be older than some of your parents. No, is that true? Yeah, it's older than them. All right. Skip that one. On to the next one. We are going to do this one. The good news, though, is that this is one we'll see maybe again. Administrator at a large university wants to conduct a survey to estimate the proportion of students who are satisfied with the appearance of university buildings and grounds. Sorry about that. Let's zoom in a little bit, look a little closer. All right, so we got a big school, 70,000 students. Let's label some things. 70,000 students at the university. That's the big N. That's the population. 500 students, that's the little n. That's the sample. We want to know about what does everybody feel, but we don't actually want to talk to everybody. So we're going to talk to some people. All right, let's consider. Because of financial constraints, money. Money. That's why we don't take censuses all the time. It costs money. The first method the administrator is considering consists of taking a convenience sample. Okay, convenience, we've seen that word. Get my highlighter out. Convenience sample to keep the expenses low. A very small number of students, a very large number of students will attend the first football game of the season, and the first 500 students who enter the football stadium could be used as your sample. Okay, what's the problem? Why might this sampling method be biased in the producing an estimate of the proportion of students who are satisfied with the appearance of building and grounds? Let's talk about what a full answer to that would look like. Selecting the first 500 students at the game. All right, so we're just kind of repeating some words back at them. May be, that's two words, biased because, well, what's the problem? It's a convenience sample. If you didn't, if they said that convenience sample. So why would this convenience sample be a problem? So really the question is, why might these 500 not represent the 70,000? How are they different? How are they different? Because, well, what are we asking them about? The proportion who are satisfied with the appearance of buildings and grounds. Okay. Do you like the buildings? Because I don't know, what do you think? The 500 who show up first, who shows up first to a football game? Crazy people who like the team a lot. 500 who show up first may be big fans who love the school more than typical. So what's the problem? Okay, so why they're different. This part is like why they're different. It's kind of what this first part's about. And then why is that a problem? How's the effect? We may overestimate the proportion of students happy, satisfied with buildings and grounds. Once again, if you want to see something that's written with better handwriting than that, you can go Google AP Statistics Free Response Questions Scoring Guidelines 2013, and it will come right up. Because of a large number of students in the university, Part B. Second method the administrator is considering consists of using a computer with a random number generator. Select a simple random sample of 500 students from 70,000. Describe how to implement such a method. This is the easier one. We're going to look at one. We don't do computers a lot. I like the hat. Let's talk about how we do it. Assign each student a unique number, 1 through 70,000. Use a random number generator. You can abbreviate RNG. People will be comfortable with that. To generate 500 unique numbers in the range 1 through 70,000. I know that seems redundant. You got to write it down. We've given them the numbers. That's one part. Now we got to tell the computer something. That's another part. Okay, the RNG spits out numbers. The 500 students associated with those numbers become the sample. That's what we're looking at. You're going to find, if you'd probably try to write that yourself, you might have stopped a sentence early. You need to go a little further, explain the full process. Okay, so we're cooking along. let's take a look at one last thing on this page. How can a simple random sample be unrepresentative? Okay, take a moment, read through this, especially when conducting surveys. We want an unbiased sample. That's true. Predictions made are more accurate, right? All right. But in simple random sampling, the possibility exists to select the members of the sample that's biased. In other words, it doesn't fully represent the population. How could that happen? Well, one thing that can happen, one way that a simple random sample might be unrepresentative is that it can leave especially small groups out um, through random selection. 2% of Park Hill High School has Pacific Islander heritage, right? But I might take a sample of 100 people at Park Hill High School, and I might not get the two Pacific Islander folks that would be expected in that sampling method. So if you got smaller groups of folks, they might not show up in that random sampling, especially if you're taking a small sample. So if you want to know about all those folks, well, then maybe you're going to select a different sampling method. And here's kind of one of the big ideas. You are going to have an FRQ. You're going to have a test FRQ over this distinction. So just promise it's coming. So we've got two kind of different sampling methods. So we might call these advanced sampling methods. We don't want to do something simple random sample. We want to do something a little more complicated. We have this thing on the top called stratified random sampling, and we have this thing on the bottom called cluster random sampling. And we got to know, what does that mean? Stratified random sampling is when the population is divided into strata. A stratum is a homogeneous subset of the population. What does that mean? Homogeneous, something in common, some common characteristics. Okay, then we take a simple random sample from each strata, and then we combine them. So what are we doing? We would be kind of taking these groups and we bin them out. Maybe it's 9th graders, 10th graders, 11th graders, and 12th graders. What do we do from them? We want to know their opinion about something. We would not just take one SRS, but we might take 4 separate SRSs and then take those and put them together and make one big SRS combined. Okay, so that's nice if we want to make sure we've got all these different groups represented, males and females, residents and non-residents, white, black, Hispanic, Asian, religion, whatever. So if you got something, some characteristic that makes a difference, you stratify on the characteristic, on the thing that makes a difference in the response. If we think grade is what makes the difference, we stratify on grade. If we think gender makes the difference, we stratify on gender. If we think it's religion, we stratify on that. If we think it's the zip code you're living in, we stratify on that. The idea is if we think that some characteristic leads to different responses, we stratify on that characteristic. That's nice if we want to make sure we got everybody represented. If we want to just be a little faster, cluster is nice. Cluster is nice because it's going to be a little faster. What's it going to be? A cluster is like, I don't know. We want to do some selection, and we want to do it quickly. Well, we divide folks into clusters. A cluster is a heterogeneous subset. So what's that mean? A cluster it's a mixed group. Then what do? We take a simple random sample of clusters. What's a cluster at Park Hill High School? It might be like lunches. lunch, what do they call them? Periods? I don't know. Think of that. We got what, 8 lunch periods? One, two, three, four, five, six, seven, 8. And each lunch period is a little different. It's got juniors, freshmen, sophomores, seniors, folks from all over. So what are we going to do in this case? We're going to take an SRS of entire clusters. Say we want to talk to, I don't know, 400 people from Park Hill High School. How are we going to do that? I don't know. Pick 2 of these lunch periods out. So we randomly select, I don't know, everybody from 2 and everybody from 5. And then we talk to everyone in 2 and 5. So what do we do here? We got some groups that are already existing. Natural groupings are obvious and available. This is a nice way to take samples quickly. So this is a fast way for cluster. This is maybe a more representative way for stratified. Next page, we got some pictures. I like this image a lot. Know this image. Because it makes me think about the difference between stratified. Over here on the left, we have stratified, taking a few people from each group. Over on the right, we have cluster, taking entire clusters. Over here, the SRSs are within, and over here, the SRS of whole groups. Different distinctions between the two to help you know the difference. For some of you, the definition alone is going to be enough for this to make sense. For others, take a moment, read through these. This is the point that gets people the most. In cluster sampling, we take whole clusters. In stratified sampling, we select within strata. So just some more ways to think about the distinction between the two. What do I have here? I have another comparison. Another way to think about this. Nothing actually to write. Another way to think about this. Multiple choice example that I'm going to skip for the sake of time. Down here at the bottom, we aren't going to skip the bottom, no, because it's part C of a question we've already done. Let's take a look at it. You take a moment, pause, read through it, and then we'll consider this together. Pause. Okay. An administrator at a large university. Okay, with the people, we want to know, hey, you like the buildings and the grounds. Because stratification can often provide a more precise estimate. Okay, more precise estimate. The third method the administrator is considering consists of selecting a stratified random sample of 500 students. We have 2 campuses and male and female students at each campus. Makes sense. Under which circumstances would stratification by campus provide a more precise estimate of the proportion of students who are satisfied with the appearance of the university building and grounds than stratification by gender? When is stratifying by campus better than stratifying by gender? When is, take a moment, write that down. This isn't part of your answer. This is the motivation. When is stratification by campus better than stratification by gender? Greater than symbol there. When's it better than doing it by gender? Well, take a moment, flip back, and I wrote something down for you predicting this was going to be coming. Stratify on the thing that makes a difference in the response. Stratify on the thing that makes the difference. So when would it be better to stratify by campus than by gender? It would be better to stratify by campus than by gender when there are bigger differences in opinion between campuses than between genders. Consider Park Hill and Park Hill South high schools. I think I'd stratify on campus if I was asking this question because I don't think boys and girls at the schools are going to have that big of a difference. But I think the people over at South might like their building a whole lot more than people here. Maybe one campus is much nicer. PHS versus PHH. Great times. Okay, fine. One question left, one FRQ left. And it's one for you. I am going to tell you to pause it. Try it on your own. This is a question that probably might take you 10 minutes. Take a moment, pause it. I'm going to keep doing it right now. And then go look at the scoring guidelines. So what do we got here? We got an apartment building, 9 floors. Each floor has 4 apartments. Great. Want to put some new carpet in. That makes sense. To see how well it wears. Okay. So we want to only put it in 8 apartments. The figure below shows the building with their apartment members. Only the 9 apartments indicated with the asterisk. Okay, asterisk means there's children in the apartments. Great. For convenience, the apartment building owner wants to use a cluster sampling method in which the floors are clusters. Okay, so if the floors are clusters, that means we select entire clusters, floors. Describe a process for randomly selecting 8 different apartments. Well, each floor has 4 apartments. To select 8 apartments, we must select 2 floors, right? So put the numbers, what are our 1 through 9? We got 9 floors, 1, 2, 3, 4, 5, 6, 7, 8, 9 on slips of paper. Put the papers in a hat. And what do we got to do then? Shake the hat. Shake the hat vigorously. Got to really shake it. And select 2 slips without, we need that without replacement. Hand hurts. I haven't written all summer. We aren't done though. We need to say what are they? Apartments on those floors get new carpet. Okay, fine. We're cooking. That's the best way, though. Part B, an alternative sampling method would be to select a stratified random sample of 8 apartments, where the strata are apartments with children and apartments with no children. Stratified random sample of size 8 might include 2 randomly selected apartments with children and 6 randomly selected apartments with no children. In the context of this situation, context, that means we need to go back. When we see that context thing, what's context? Apartment, carpet, children, When we see context, we need to use those kind of words in our answer. Give one statistical advantage of selecting stratified as opposed to cluster. Well, what could happen if you do cluster? What if I got the third floor and the fourth floor? If I got the third floor and the fourth floor, what's wrong with the third floor and the fourth floor? Cluster sampling can yield samples with no children. Cluster sampling can yield samples with no children. Why is that a problem? We don't know how the carpet's going to react to children. If there are no apartments with children, we cannot observe the effect of children on the writing. That's what these notes are going to look like. If I skipped it in the notes, you can skip it on the homework. You probably watched this in faster than 1 time speed, but if you didn't, can next time. Go do the homework. Make some note cards. See you soon.